Hey, I know this is the episode about the power of water, but what are you doing with that, Andy? You won't need that here.
Well, not now, but there's some serious rapids up ahead. I'm not taking any chances.
This time on Turtle Island, it's all about the power of water. We find out how electricity is made from the power of tides and waterfalls. We go diving on some amazing shipwrecks in Fathom 5 National Park. And we learn how to count fish in one of the biggest lakes in the world. Stay tuned for the shocking results. Our world is full of amazing people, animals, and plants, and finding ways to keep it that way is something we can all do. Join us on our mission to keep Mother Earth healthy and strong. I'm Chuck. I'm Andy. And this is Turtle Island.
Water is a powerful force. It can be used to generate immense power and provide us with electricity.
One form of water power is called tidal power. That's the power of the tides as they go in and out. And the Fundy tides on Canada's east coast are among the most powerful in the world. I still don't see anything.
Oh, you will.
The tides here in the Bay of Fundy are extremely powerful, so powerful that we can actually get some of that power from it.
Andy, the first thing you need to know about tides is that the moon plays a big part. Absolutely, Chuck. The oceans are just naturally attracted to the moon. Yep, and it all happens because of gravity.
The moon affects a lot of things here on the Earth. Its gravitational pull is pulling on trees, it's pulling on rocks, it's even pulling on us. But we really see it happen, it's pulling on water.
The Bay of Fundy is some of the highest tides of the world, and we're capturing them right here at Annapolis Royal. This is the site of the only tidal turbine power plant in the entire Western Hemisphere. And it's so rare because it uses the power of the tides and the oceans to make electricity. I'm Margaret Murphy, and I work here at Nova Scotia Power. The water from the Bay of Fundy enters the Annapolis River and just flows upstream. Huge volumes of water pumping through this area, creating incredibly powerful flows. Here in this part of the world, the Bay of Fundy, that tidal energy is actually increased by the fact that it's such a narrow channel. Some people call this the bathtub effect. So picture if you're in a bathtub and you start sloshing the water up and down the bathtub. Because it's a very narrow basin of water, you'll find that as you slosh back and forth, it just builds up higher and higher and higher. So that building up of the water, that building up the tides is really increased here. To give you some idea of the size of this machine, this is me, and this is the turbine.
Whoa, Andy, that's a huge machine. That turbine is 7 meters across, about the size of a big bus. It's massive, Chuck. Hundreds of cubic meters of water move through there every second. It's awesome.
Water builds up behind the head ponds, and then when it reaches the right level, these gates open automatically. With tremendous force, the water strikes these blades on the turbine, spinning the turbine, creating the electricity that flows out onto the grid. In Nova Scotia, there's a huge tradition of really respecting the ocean, respecting the marine environment. So we want to move towards technology that can work with the ocean. So our vision for the future is an entire farm of tidal turbines on the ocean floor, producing electricity with no environmental impact.
Like a lot of things in nature, the tide is something that always happens. But according to legend, this wasn't always the case. Long ago, there were no tides, making it impossible for many creatures to reach food under the water. But Raven had discovered that an old woman was in charge of the tides, so he went to see her. When he arrived, he found why there were no tides. The old woman was using a rope to hold back the water. Thinking quickly, he blew dust in her eyes, and she dropped the tide line. The water rushed out, but Raven felt bad and agreed to heal the old woman's eyes if she promised to let the tide go out twice a day. And it's a promise that the old woman has kept all this time.
Sometimes the power of water goes beyond our ability to harness or even escape it.
That's when the last place you want to be is on the water. That's when you get something called a shipwreck, which is likely what's going to happen to us when we hit these rapids.
Oh, come on, Andy. How bad can it be?
Chuck, you remember Titanic?
The movie?
The boat, Chuck.
My name is Scott Parker. I'm a park ecologist at Fathom 5 National Marine Park and Bruce Peninsula National Park. We're in Tobermory, Ontario, Canada, on the end of the Bruce Peninsula in Lake Huron. In Fathom 5, we know of 27 wrecks that were totally lost. And we have 22 of them that we know where they are. So there's some other wrecks that are out there we know that were lost in Fathom 5, but we haven't found yet. And when you look at the stories as to why they were wrecked, most often it was the fall of the year when the gales and storms were severe. And also, the Niagara Escarpment, which you see on land here, continues into the water, and there's lots of shoals and reefs and islands. And when you're navigating a vessel, specifically a sailing vessel or a steamship where you're towing barges behind you, it's treacherous. Fathom 5 Provincial Park was created in 1972. The Ontario government at the time established the park to protect shipwrecks and offer opportunities for diving. It has been a popular diving location for decades.
Diving in Fathom 5 can be really dangerous. A diver has to be pretty experienced to do it.
Roger that, Chuck. Remember the last time we dove there? How cold and deep it was?
Yeah, Andy, and I also remember the scared look on your face.
Hey, I wasn't scared. I was just focusing.
No problem. Where's 14160?
Yeah, Collins 8516. There's a few wrecks in Fathom 5 where the hull is still intact, the sweepstakes being one of them. The wreck has been broken up, and that's all old oak planking. Over 100 years later, that wood is still down there. You can see part of the rudder. There's the anchor chain was a little further up there, and the anchor. The centerpiece of this whole wreck is the boiler. It's right here, very close to the surface. And the boiler, of course, is one of the most important pieces of machinery on a steamship. We are at the site of the wreck Arabia. It was transporting a load of corn from Chicago to Midland. For many years, we didn't know where it was, and some of the local fishermen would report catching whitefish with corn in their bellies and in this area. And so it gave us a clue that there was something down on the bottom.
Andy, this area is so important because of the shipwrecks. They've been protected, but now the whole environment is being protected too.
You said it. You really can't protect one without the other. And people in the area are doing a great job taking care of this special place.
I think this area stands as a good reference to show how an area can be lived in sustainably, how important our parks are for our well-being.
Hey, Chuck, I was thinking about very cool creatures today.
Let me guess, Andy. Tasmanian devils.
The Tasmanian devil is a cool creature, but I was thinking about rockfish.
They're awesome fish. They live on the Pacific coast in really deep water.
What I think is awesome is scientists think some species live longer than any other fish.
One rockfish they found was about 205 years old. Hey, I wonder if I'll live to be 205.
Chuck, humans can live to be just over 100. That's it.
Yeah, but with my healthy eating and exercise, I just might surprise you.
Speaking of healthy eating, some rockfish love to eat shrimp. Hey, I love to eat shrimp too.
Yep, me too. But rockfish are in trouble on the Pacific coast, pretty much from overfishing.
Yeah, too many of them are caught in bottom-dragging nets.
And there are lots of different species of rockfish, which all should be protected.
Hey, Chuck, I kind of feel like shrimp today.
Yeah, you kind of look like a shrimp.
Very funny, Chuck.
You know what Niagara Falls looks like, Chuck?
Yeah?
You know how powerful that water is?
Yeah? It generates massive amounts of electricity for Canada and the United States.
Well, the rapids on this river make Niagara Falls look like nothing. We should suit up now.
Suit up?
falls are so awesome. 14 million people visit the falls every year. That's how amazing they are.
Pretty amazing, Andy. And did you know that the first humans came here 12,000 years ago? It was a great place to grow crops and hunt for food.
And after that, it was an important place for Iroquois nations and fur traders. The name Niagara means thunder of waters.
And speaking of all that water, 2/3 of it doesn't even go over the falls. Where does it go, you might ask? It goes to make electricity for both Canada and the United States.
My name's Dean Norton. I work for Ontario Power Generation. Right now we're located in Niagara Falls. It's the largest hydroelectric plant in Ontario. The generation of electricity using water is actually a very simple concept. The water flows up to the hydroelectric plant, at which point it enters pipes called penstocks. As the water flows down the penstocks, the pressure increases to the point where it enters into the turbine and causes the turbine to turn. The turbine's connected to a rotor, which is just a large electromagnet, and as the rotor turns inside of a coil of wires, it causes a current to be developed, and you've made electricity. From there, the electricity is distributed to your homes and businesses and factories. They're very large hydroelectric plants, and they produce almost 10% of the energy for the province of Ontario. That would be about 10 billion kilowatt hours, or enough energy to power 1 million homes.
Here's something I bet you didn't know, Andy. By diverting so much water away from the falls to make electricity, the natural process of erosion has been slowed down quite a bit.
That's good, Chuck, because erosion can really wear on you.
Good one, Andy.
Historically, the erosion at the falls was as much as 1 meter per year, and that has been reduced to about 30 centimeters per year. Hydroelectric generation is environmentally friendly, and it's important that we provide this resource to future generations. It's clean, renewable, and reliable.
Well, there you go, Andy. Another amazing story about the power of water.
Yeah, it's electrifying.
Water not only keeps us, but the entire planet alive.
So keeping our water clean is essential to life on Earth. Did you wash that paddle before you put it in the water, Andy?
Yeah.
What'd you wash it in?
Water.
Well, one of the things I've found living on the ocean is when you throw your garbage away, it all eventually ends up in the ocean. And when it ends up in the ocean, then it usually ends up on the shore.
When I first came up to Tofino, British Columbia to work for the national park up here, I found a Japanese glass fishing float. I remember doing a little dance on the beach when I found it. It was one of these events that I think you'll always remember. Much of the stuff that I collect ends up being thrown out, and it goes to the garbage dump because you don't want these kinds of materials to remain on the beach.
Peter Clarkson came to Tofino as a park warden for Pacific Rim National Park. He loves to beachcomb, and he started finding cool things. Well, some people would call it garbage.
But to Pete, one man's garbage is another man's, well, Pete's treasure.
Just the shapes of them, the colors, the way they were worn by the ocean, all that stuff really inspired me. So I would take those things home and start using them to make different bits of art. And I've been doing that for about 10 years now.
You know, Andy, anyone can make art out of garbage. It's so cool, Chuck. I want to try to make some beach garbage art. Wonder how you get an idea.
Anyone can make art from debris and from garbage. It's just a matter of letting yourself be free and creative when you find that stuff and following what looks good to you. The rest works out. And at the end of the day, the beach is cleaner.
See, Chuck? Water even has the power to help us make art.
Yeah, it just takes a little time and a little thought. From around the world, scientists, students, artists, and the people of the North have joined forces to study the Arctic regions of the globe to help us understand our world. This is International Polar Year.
Hi, I'm Rianne Salmon. I'm the Education and Outreach Coordinator for International Polar Year. My background is as an atmospheric chemist. I lived in Antarctica for a year and a half running a lab measuring crazy molecules in the atmosphere. It's all related to climate change research. And when I came back, I thought that everyone would be really excited, and it turned out that the society I came back to didn't really think that climate change was happening, and I figured that actually that might be an area that we needed to spend a bit more time focusing on. And I work with scientists trying to get them to get into the classrooms, get out into the field, and talk about what they do. I'm an atmospheric chemist. I study the air and I study the molecules in the air, but sometimes I see a really strange signal and I don't know what it's about. None of my friends and none of my colleagues know. But what I really need to do is talk to a biologist, because I think maybe this chemical signal has come from the ocean, and it might have come from life in the ocean. And normally there aren't any biologists around in the place where I do my research, but during IPY you can count on it that there is going to be a biologist or a geologist or a social researcher or a space physicist around in a similar place to where you've been, who can maybe help you answer some of those really key questions.
The power of water can also be pretty subtle. It can move things gently and gradually, as well as in one massive wave.
In fact, tracking waves is a part of what's done through a program called Students on Ice. Scientists and students from around the world travel to the poles to study them, and to study the currents that carries the water from the poles
to the rest of the world. Hear that, Chuck?
No?
We're at the rapids.
Water current is essentially like a river that flows through the ocean. So the ocean is divided into many different currents that flow in different directions. Water currents are very difficult to study because you can't see them just by looking out across the surface of the water. They're invisible to the naked eye. So one of the best things that we can do is to put objects into the water that will then drift along with the currents.
To track currents now, scientists use really cool cylinders called Argo floats.
And Chuck, they are really high-tech, with sensors and GPS on them. They even have cell phones that call back to shore with info.
The bottle drop program is a great example of ingenuity in making a low-cost but very effective scientific program.
Basically what we do is we have the students get a bottle, write a note in the bottle. You don't have to write it in a scientific format. Make it more happy and informal and personal.
Each bottle has inside it a label which is placed by the student so that it gives a unique identity to that bottle. It's then sealed so that it's watertight, and it can then be thrown into the ocean where it can float for many, many years if need be.
Okay, Ingrid.
Are we ready? Yeah! I'm so excited!
We all watch the ball soar through the air and splash down, and we all cheer when it hits the water. And then it's the ocean currents that take over.
All the oceans of the world are interconnected. So a bottle that's thrown from here off the coast of Baffin Island can drift down into the northern Atlantic Ocean, and from there it could theoretically go anywhere.
From the Students on Ice, we've had a bottle that was thrown in between Iceland and Greenland, and it ended up in Wales. So that's right across the entire North Atlantic Ocean. That's a long ways.
Eventually, somebody may find it. And if they do, maybe they will read English, and hopefully they will, and they'll get in contact with the people at the Institute of Ocean Sciences and tell them exactly what happened to this bottle. And it will tell us something about how the ocean here is connected to the oceans everywhere else.
Hey, you know that saying about how many fish there are in the sea? How many are there? We'll find out after these rapids!
Andy, these aren't rapids. These are
I'm Rick Portis from the Toronto Region Conservation Authority. Today we're collecting fish. We're going to use the surveys that we're doing today to figure out what type of fish are in this area and find out what kind of diversity we're going to get. Counting fish is important, but the more number of types of fishes that we catch tells us if we have a more healthy system. If we're only catching 1 or 2 species, it means that system is not so good.
Andy, on Lake Ontario, Rick and his crew go out on a special boat called an electro fishing boat.
It's called the Night Heron, and it's designed to catch fish using electric currents. Ouch!
The fish are all right. They're just given a mild electric shock, and then Rick's crew can pull them out with their nets.
Those prongs you see bring the fish right up, and once they get close enough, they get zapped. And then they can be caught for Rick to study.
This is the boat where the guys are going to sort them out into the different species. That's a largemouth bass, big predator species. They'll start eating fish at about 1 or 2 years of age, and then once they start eating fish, they really start putting on the pounds. This is actually a goldfish. It's usually not a good idea to take them out and let them go into the wild, because this is what they turn into. They don't belong here. Goldfish are actually an Asian species. Before we release them, we'll actually take them and we'll measure them and weigh them, count them, and then once that's all finished, then we'll put them back in the water. We're shocking away, and we're going to see if we can get some larger species. During the nighttime, we get a lot of the small little forage species feed on all the little vegetation and such, and with those small little forage species, they get the big, large predator fish come in to feed on them as well. After out for a short little night run, this is what we've come up with. We've got a really nice northern pike, a fish that likes to eat other fish. So basically, this is the top of the food chain. One of my favorites. This is a common carp. This is actually an invasive species in the lake. These guys essentially root around on the bottom of the lake. They root up plant material, stir up sediments. These were brought over in the late 1800s as a food source from Asia. You can see the size of these guys. They're basically like little pigs on the bottom of the lake, just rooting around.
Looks like the fish populations in Lake Ontario are doing pretty good, Andy.
That's true. Over the last 20 years, the fish population has really grown. Rick and his crew are seeing 30 to 40 species a year.
Wow, that's a lot of fish to count. And it means that some of the changes we're making are actually helping to make the water cleaner and healthier for all of us.
Yup. We should never take the power of water for granted. It's up to all of us to make it clean and safe.
And there you go. There's another successful night of electrofishing.
Wow, those rapids really snuck up on us.
Told ya.
I guess that river was way more powerful than I was expecting. See you next time.
Thanks for watching.